Here's a calculus free response question. This is from the era of questions where the number 3 is not a calculator question. This is not calculator allowed. Alright, so let's see what we got here. I got a graph of some function f. Looks very geometric-like, so I bet I'm going to have some areas to find. On the interval from -6 to 5. That's interesting because this only goes to -2. So we don't know what's happening 3, 4, 5, 6 over here, but maybe we'll have to do something with that. Alright, the graph above shows a portion of the graph of f, 2 line segments, and this is a quarter circle centered at the point 5, 3, so the radius of the circle is 3, so the area, that's a quarter circle, so it'd be like 9 pi over 4, right? Pi r squared divided by 4 for that quarter of it would be that little wedge. It is known that the point 3, 3 minus the square root of 5 is on the graph of f. Okay, thank you for telling me that. I wonder how we might need that. But got that height right there. Okay. If the area from -6 to 5 is 7, then find the value of the area from -6 to -2. Well, -6 to -5, if you think about this in terms of geometry, the whole area from -6 to -5 would be equal to the area from -6 to -2 plus -2 to 5. That's just basic geometry, right? If you take the area from -6 all the way to 5, well, you could just break that up into those two pieces. And it looks like this is the thing I'm trying to find. They told me that this is 7, and that for the area from -2 to 5 I can find from the graph here. Okay, so that's pretty easy. Let's do it. So I'm going to write this little expression here out, or equation. The area from -6 to 5 is equal to the area from -6 to -2 plus that. Okay, so this is 7 is equal to that. And then this area from -2 to 5, let's see, that right here and this right here cancel each other out. This right here and this right here cancel each other out. This has an area of 2. There's different ways you can find that. You can do square with a triangle on top. You could imagine cutting this little piece off and inserting it right here, and then it's 2 square units. But one way or another, that area is 2 plus then this area is this square, 3 by 3 square, minus this quarter circle. So that is a 3 by 3 square minus the quarter circle. Okay, so that means that the area that we're looking for, or the integral we're looking for, is equal to 7 minus 11 plus 9 pi over 4. All right, part B. Evaluate this. Okay, so taking the integral of a derivative, I know how to do that. So let's see. I want to find, I'm just going to recopy it here. Actually, I'm going to split it up into two integrals because, well, yeah, I guess I'm going to do that. You don't have to do this. You take constants to the outside, so you could do that if you want to. But either way, the 2 on the outside here is going to continue to be on the outside there, and then the antiderivative of f prime of x is f of x from 3 to 5. Oh, that's all we needed to know about that square root. Plus the antiderivative of dx is x, so that's 4 times x from 3 to 5. You could have done that with leaving the constant in there. That's fine. And then that is 2 times f of 5 minus f of 3 plus 4 times 5 minus 3. F of 5 is 0, and f of 3 is 3 minus the square root of 5. Okay, so let's see if we can get this all done right. F of 3 is 3 minus the square root of 5 plus, this is just 4 times 2. You could leave it like that. There's no reason to simplify more than that unless you have an obsessive compulsive tendency like me that forbids you from leaving things alone. So I'm getting 2 square root of 5 plus 2. But yeah, I mean, you don't need it. You can't leave it like this because you have not substituted for these things, but as soon as you have an all numerical answer, you can stop simplifying. The function g is given by g of x is equal to the area from negative 2 to x, f of t dt. The fact that these are t's here, only because we already used the x, does not mean anything else. It's still that same f function. And right off the bat, function defined by integral, that means that g prime is equal to f, because if I took the derivative of both sides, g prime is equal to derivative of integral. That cancels out. That's the fundamental theorem of calculus. All right, what do we want to do here? Find the absolute minimum value, absolute minimum check endpoints of g on the interval from negative 2 to 5. So where is g prime equal to 0? And then check the endpoints. So negative 2, 5, and anywhere else in between where I need to check where g prime is 0. Well, g prime is the same as f. So where is that equal to 0? That's equal to 0 at negative 1 and at 1/2. If I'm looking for a, what am I looking for? A minimum? Maximum. I'm looking for a maximum. Maximums have to happen when the derivative goes from positive to negative, right? And this is g prime, so positive to negative. I only need to check negative 1 there. I don't have to check the 1/2 because that would be a minimum, right? The derivative is going from negative to positive there. All right, there's my x values. I want to find my g values for those. So let's see. G of negative 2, if I plug negative 2 in here, then I'm talking about the area from negative 2 to negative 2. That's 0. If I plug negative 1 in here, I'm talking about the area from negative 2 to negative 1. That would be 1/2. If you plug 5 in there, that would be the area from negative 2 up to 5. And I think we found that already, didn't we? From -2 to 5. Oh no, we found -6 to -2 to 5. I guess -2 to 5 was this part of that. So we kind of did that already. We didn't have it as a separate answer. So that's 11 minus 9 pi over 4. And we want the absolute maximum. So you have to do a little bit of estimating here. If you think pi is like, about 3, then a little bit bigger than 3, then that's like 27. 9 times 3, right? 27, or let's say 28 divided by 4 is 7. So 11 minus 4, this is bigger than, it's bigger than 0. So, and it's bigger than a half. So the max is, I'm going to give both answers. I'm going to say what it is, and I'm going to say where it happens. Because now I don't care what they asked for. I've got both versions of the answer. In fact, they did want the absolute maximum value of g. That would be this. But I'm always going to give both, because then I got my bases covered. Part D, we're going to do a little limit here. And when I'm a student in calculus class and I see a limit, there's some like early Chapter 2 kind of limits that we need to know about, but something like this, I'm feeling L'Hopital's rule, right? So x approaching 1, if you plug, let's see, 10 to the first, I'm just checking to see if, in fact, this is L'Hopital, minus 3 times f prime of 1. F prime of 1 is 2. Oh, this is not L'Hopital's rule. Huh. How about that? That's a fake out there. Because when you plug in, I don't care what the bottom's equal to, it's not L'Hopital, because when you plug in 1 here, you are not going to get 0 on the top. Because f prime of 1, the slope here, that's just 2. So 10 to the first, let's see, f of 1, whatever that is, I'll figure that out in a sec. And then minus the arctan, same as tangent inverse of 1. So that's 10 minus 6 over f of 1 is, this is the f function, so it's just 1, minus the arctangent of 1, the angle that has a tangent of 1 is pi over 4. And that's it. So, I mean, you could do 10 minus 6 equals 4, if that makes you happy. If you think this is a fraction in fraction in fraction, then you could multiply the top and bottom by 4. That's the same thing too. Multiply by 4 over 4, but this is fine right here. That's not fine because you haven't substituted those things. I don't know, I don't think you can leave that as tangent inverse 1. I think that this question is at least a little bit about that.